Hi guys, good morning. Another video on AC204. So here we are talking about explore Azure storage. So now we are in the topic or the path that says develop solutions that use blob storage. And here we have a module that says explore Azure blob storage. So Azure blob storage is Microsoft's object storage solution for the cloud. Can store massive amounts of unstructured data. So blob storage can store unstructured data for us. And what is Azure blob storage designed for? So Azure blob storage is designed for saving images or documents directly to the browser. So you can access Azure blob storage using your browser client, so your Chrome, your Edge, or whatever the case might be. Storing files for distributed access. So you can store your file for distributed access. It is also made for streaming video and audio. It is also useful to writing log files. So you can write your log files to Azure Blob Storage. For storing data for backup and restore, disaster recovery, and archiving. Storing data for analysis by an on-premises or Azure hosted service. So you can push your on-premise information or Azure hosted service data to Azure Blob Storage for data analysis. And access objects through HTTP or HTTPS via a REST API. So Azure Blob Storage gives you ability to access information or objects inside the blob through HTTPS via an REST API, Azure PowerShell, Azure CLI, or an Azure Storage Client Library. So this is code-based type or library. Azure Storage Account is top-level container that provides unique namespace for Azure storage data. So Azure, as I mentioned there, Azure Storage Account is a top-level container, right? Storage account is a top-level container. Container that provides unique namespace for Azure storage data. What are the types of storage accounts that we have? We have standard storage account and a premium storage account. Obviously, you know that with Azure, it will be feature based, so there will be different features for the different types. So standard is a general purpose V2. It is mostly it is recommended for most use cases. So your most use cases that you'd have for a blob storage, they can be covered on standard. However, with premium, they offer higher performance by using solid state drives. This gives the ability to choose block. You have the ability to choose between blobs, page blobs, or file share account types. So with standard, you want to have the different types of blobs that you choose. Technically speaking, you'd have a single type of blob that goes with it. Cool. The following table describes the types of storage accounts recommended by Microsoft for most scenarios using blob storage. So storage account type versus supported storage service and the usage of that supported storage service. So on a general standard general purpose V2, you have the ability to use a blob, a queue, and a table storage, queue and a table storage and Azure files as your storage options. With premium blobs, you have blob storage. For premium page blobs, you have page blobs only. For premium file share, you have Azure file share. So what are premium file share accounts used for premium storage or account type for file shares only? Then premium page blob is meant for premium storage account type for page blobs only. Then premium blob, as we mentioned here, it is for it's a premium storage account type for block blobs and append blobs. Recommended for scenarios with high transactional rates or scenarios that use smaller objects or require consistent low storage latency. So if you want low latency or storing small object on high transactions, you typically use this premium blob. Then standard V2 is a standard storage account type for blobs, file shares, queues, and tables. This is recommended for most scenarios using Azure storage. If you want support for NFS file shares in Azure files, use premium file shares account type. Then we have access tiers for blob data. There are different blob accessing options based on usage patterns. Each option optimized for a particular pattern, and when chosen correctly, saves costs. So if you choose your pattern correctly, you will save costs, right? That's something to take note of. Uh, so there we're saying what do you call usage patterns. Then here we have available access tiers. So for a storage account, we have or a blob, we have different storage access tiers. So we have hot, we have cool, we have archive, right? Hot is optimized for frequent access. Access is cheaper while storage costs more. And for cool, cool is optimized for storage. Access is more costly. For blob stores, stored for about 30 days. So when you when it comes to cool storage, your blob should be infrequently accessed and should be accessed around about what do you call about 30 days. Archive only available for individual blobs. You cannot archive what do you call, let's say a container or something along those lines. You can only do this on the blob level, and it's for accessing data. When accessing data is more expensive, while when you're using archive, accessing data is more expensive than cool or hot, while storage is cheapest. So it's cheaper than hot, cheaper than cool as well. Storage for about 180 days has retrieval latency. So when you're using archive and you try access the file within 180 days of you archiving that particular file, if you have to rehydrate it, it will take time. Essentially, it does not rehydrate immediately. You can, however, do that, but it comes at a particular cost, and it will typically take a day or hours essentially to do the hydration. And here they say you can switch between these access tiers at any particular time. So you can go to a blob storage and do whatever that you needed to do. What do you call at any particular time. Julio, just doing something on the side. So with me, checking something here. Okay, that's what I was looking for. That. Let's create something. Um, um, so effectively what I've done here, if you look at this, I have a storage account. And when you go into the storage account, what then happens is I went to containers. Into containers, I have blob one. Blob one is it's essentially a container, it's not a blob itself. Inside the container, you can have multiple blobs. So here I have a blob called postman.exe. Then when you look at that, the access tier is currently on hot. That's what we're talking about. So this is more for high access, and the storage is more costly. So what I can change here is just make sure. Okay, there it is. There's a change tier there. If you click on change tier, it will then tell you which one do you want to put it as. You can, I'm changing that because it's from hot. Now I'm putting it down to cold. So by default, any blob you add gets added as hot unless you specify. So now it's on cool. So if I wanted to access this, it would typically be more expensive to access it, but storage is cheaper than hot. Then on the last option, what I could do is change this to see the shows me the change on date. What I can do is I can change it to archive, and they say setting this to archive will make your blob inaccessible until it's rehydrated to hot or cool, which may take several hours. That's what I was mentioning with that. So you can do that archive if you wanted to, and then should put the blob in there. If you wanted to hydrate it, let's just do that for now. So it's in archive state. If I wanted to, let's say, for example, change tiers and set it to hot, it would say rehydration of a block archive to hot or cool may take several hours. That's what we're talking about. So this is for data that is less inaccessible. So you can't really access this particular blob. Okay, so you can access this thing essentially. Folio. Let me just delete that. Okay, cool. Then here we have storage account. And the storage account, we say storage account provides a unique namespace. So essentially, a storage account contains a lot of things. So as we saw on what I was presenting there, on my storage account, when you look at that storage account options, no browser, no. So if you look at the storage account, this is on the storage account, you can see it has containers, file shares, queues, and tables that I can create as and when I require. Cool. Every object stored in an Azure storage has an address that includes the storage account name as part of the endpoint. Okay. So every every object stored in Azure has an address that includes the storage account name as part of the endpoint. Storage account name, my so the structure would be this. Let me do this. Storage account name, then dash dash my account. That would make the what do you call the URL essentially. I'll do that. So cool. I'll try create something. Should be deleted after this demo. Okay, cool. So they are talking about this thing, Blob URL. Cool. So cool. So if you look at, I've created one of the blobs in there, and when you look at that, you have your, what do you call? You have your storage account there. Then I have a container name. Inside that container, I have a blob called squirrel process start.log. Then these are the properties of it. So when you look at the properties and you copy the, what do you call, the URL. So I pasted the URL here. If you look at that, this is essentially what do you call, the storage account name. Then what I'm accessing there is a blob service. So if I was on a file share, it would say .file share or something. Then that's my container, and that's my what do you call, the actual blob that I'm accessing. So that's what they mean when they say it gives a namespace. That's a namespace essentially. So anything that I access that's within that storage account, on the URL it will have the name of the storage account there. So containers organize blobs similar to directories in a file system. So similarly, you saw what happened. I did a container after container. I could put multiple blobs, so you can create multiple containers in a storage account to keep multiple blobs as and when you need. You can have unlimited number of containers, which can have unlimited number of blobs in them. Container must container name must be lowercase, so you can't have a container name being uppercase. That's that. So blobs, your storage supports three types of blobs. So the blobs that we have is block blobs, we have n blobs, we have page blobs. Block blobs store text and binary data for up to 4.7 terabytes. Right? That's the limit there. Made from blocks of data that can be accessed individually. Pen blobs made from blocks like block blobs, but optimized for append operation. The idea here is to use append blobs for logging, right? Uh, then page blobs stores random access files up to 8 terabyte in size. This can store virtual hard drives, VHD files, and serve as disks for Azure virtual machines. So you can use page blobs to store their actual virtual hard drives on the, what do you call, on Azure storage blob, and it will power basically your virtual hard drive for your virtual machine as your virtual machine. Cool. As your virtual storage security features. So on the security features that are involved in, what do you call, Azure storage, we have all data stored in Azure storage is automatically encrypted using what do you call, storage service encryption. So SSE, as they name it. Then Azure AD and role-based access supported for Azure storage for both resource management operation and data operation. So you did RBAC. So technically, even if I give you my URL to my blob that you saw there, you won't be able to access it until you have Azure AD and rollback access permissions, essentially. And assign rollback access control scope for storage account, and assign rollback access control roles scope to subscription, RG, storage account or individual container in a queue or a queue, right? So we can assign role-based access through inheritance on the subscription, through inheritance on the resource group, or directly on the storage account, or actually a lower level on the individual container or the queue itself. Data can be stored in transit between application and Azure by using client-side encryption, HTTP, in client-side encryption, HTTPS or SMB 3.0, right? So to secure your data in transit between application and Azure, you can use client-side encryption. So this is where the customer encrypts their information, or you can use HTTP, or you can use SMB 3.0 to do the encryption, to do the security there. And encrypt VMOS and data disk using Azure disk encryption. So if you are storing your virtual hard drive, you can encrypt your VMOS, and data disk using Azure disk encryption. It delegated access to data objects can be granted using a shared access key. So you can use SAS shared access key to actually give users access to this if you don't want to give them role-based access control. Data is automatically encrypted at rest. So anything stored on Azure storage is actually encrypted when saved. At rest. That's what it means when it gets saved in Azure. Then we say it uses a 24. The encryption uses a 24 bits AES encryption to encrypt the data. This is similar to BitLocker in Windows. If you are familiar with Windows, there's something called BitLocker that does this sort of encryption at rest. While it encrypts your disk essentially. Encryption enabled by default and cannot be disabled, right? So you cannot disable encryption. Let me try see if I can get that. Security. Yeah. So if you look at that on my storage account, I went to encryption. When you get there, it already has an encryption type set to Microsoft managed keys. There's also an ability to use managed keys to encrypt your disk, storage account. I mean, all storage account resources are encrypted, including object metadata. Also, across all redundancies, no additional cost for encryption and does not affect performance. Can rely on Microsoft managed keys to manage storage account encryption key or manage the keys yourself. So that's what we're talking about with Microsoft managed versus customer managed keys. Yeah, you can use or just add that managed keys. Add that. And now those two options, those bullet points are saying for us to use customer managed keys, we can use the following strategies. Customer managed keys used to encrypt and decrypt all data in the storage account. Customer provided key on blob storage operations for granular control of encryption. And the following table compares key management options for Azure storage encryption, right? Encryption or decryption operation. Then here we say Azure, Microsoft managed keys in Azure, customer managed key, Azure, customer provided key. Oh, yeah, both actually. Customer. So we have customer managed keys. We have customer provided keys. So you can either provide the key or you can manage the key fully, essentially. Cool. Let me just take that out. So Microsoft, okay, Azure Storage Services support Microsoft. This table is not easy to read because I need to read it that way and that way. So Azure Storage Services supported. So with managed key, everything is supported. With customer managed keys, we have blob storage and Azure files. With customer provided keys, you can only encrypt blob storage and key storage. This is stored in Microsoft Key Store. This one is stored in Key Vault. This one is stored in Key Vault or any other key store that you could use. So because you provide it, so you can access it and provide it to Microsoft. Key rotation responsible. Who is responsible for rotating the keys used for the encryption? Here it's Microsoft under Microsoft Manage. And customer managed is the customer provided is the customer. Key usage for Microsoft. Here key usage is for Azure Portal Storage, Resource Provider, REST API, Azure Storage Management, Libraries, PowerShell and CLI. Customer provided also Azure Storage, REST API, Blob Storage, and Azure Storage client libraries. Uh, Key access can only be accessed by Microsoft. For customer managed, it can be accessed by Microsoft and customer. For customer provided keys, you can only be accessed by customers. Cool. So most of the customer managed keys, as we mentioned, they only support blob storage and Azure files. Customer provided only blob storage. So if you wanted to encrypt everything, essentially, you'd want to use this managed key so that you can encrypt your files and all of those type of storage services you have. Cool. Evaluate Azure storage redundancy options. Redundancy ensures maximum availability and durability in face of failure, right? Redundancy is for maximum availability and durability in face of failures. Azure storage is always okay. Azure storage always have multiple copies of the data, protect against maintenance, network failure, power outage, and natural disaster. The biggest factors when choosing a redundancy option is low cost versus high availability. So those are the two trade-offs that you'll be making. Do you want it to cost you less, or do you want it to always be available in spite of favor? So mission critical system will rely more in the side of things, high availability, while services that I can afford to go down for some time will tend to go this option essentially. Factors to consider when choosing a redundancy option includes how data is replicated in a primary region. How do you want it to be replicated where you are storing it, where your main storage account is? So do you want it to be zone redundant? Do you want it, all those type of options? Replication in secondary region to protect against natural disasters. So if your primary region, because regions in Azure are geographically different locations, if it happens that you have a natural disaster of some sort in region A and your secondary region, what do you call, is able to replicate this information, that gives you the ability to now connect to your secondary region should you have issues in your primary region. So that's what happens in terms of natural disaster. Ability for application to read replicated data in secondary region when primary fails. So automatically, when data is not available in your primary, you are routed to your secondary. Then that allows you to read the data from there. Redundancy in the primary region, data always replicated 3 times. So your data in Azure is always replicated 3 times. How many times? 3 times. I think this is an exam question, so you must know this type of numbers. Two options for how data can be replicated in the primary regions. How can data be replicated in your primary region, right? Primary region. I say two. Okay, yeah, two. We have locally redundant storage. We have zone redundant storage. So what is local redundant storage? Copies data synchronously 3 times within a single physical location in the primary region. Single physical location in the primary region. Locally redundant storage not recommended for high availability or durability solutions. Zone redundant storage copies data synchronously 3 times copies data synchronously uh, to 3 Azure availability zones in a primary region. So zone redundant, it copies them across what you call 3 availability zones in your primary region. Recommended for high availability applications along with secondary region replication. Redundancy in secondary region. Recommended for high availability, high durability, I mean. When creating a storage account, you select the primary region and a secondary region pair. the secondary region pair is chosen by Azure for you and cannot be changed, right? Cannot You cannot change that. Secondary region is chosen for you automatically. The two options for copying data to secondary region is you can have geo-redundant storage, you have geo zone redundant storage. So geo-redundant storage is local redundant storage in primary and in secondary region. That means you'll have 6 copies of your data. Geo zone redundant storage is zone redundant storage in primary and secondary region, 3 copies. But remember, with geo zone, it's more like zone redundant, where it's copied across 3 zones, 3 availability zones. So with geo redundant, it will be 3 zones in your primary and 3 zones in your secondary. Create a blob storage account type. Okay, this looks like more an hands-on type of thing. Blob storage account type is created with premium characteristics. Create a blob storage account. So it requires premium characteristics, optimized workloads with high transaction rates and that require very fast access time. Storage account name can only be numbers and lowercase letters, right? 3 to 4 characters at minimum and maximum length, and unique across Azure. Because remember, the storage account is your namespace, so your namespace has to be globally unique URL essentially. So to create blob, you need to select the premium performance on the Azure portal. Using the Cloud Shell, create that. Okay, I don't know. Location SKU. I'm not sure if I'll be able to do that because my pricing plan is not the greatest. But however, let's give that a try. Okay. So they say what we need to do effectively here is the storage account create under a resource group. So I'll just put in one of the resource groups that I have in here. This thing loads faster, it will make life easier. Okay. Okay, here I'll just provide a name. AZ24 let's name it that. We'll have dash name. This is the name of the storage account. Then I'll say call it what? Jigarabo testing something 2022 0302 0303. Oh, okay, cool. Okay. Location, we'll say West Europe because we've been having a lot of luck with that. We will say dash kind blob storage, right? Then it will say SKU premium underscore LRS. So I need to copy this command. Right, let's do that. Okay, so they are complaining about my storage account being very long. That's good that we do that validation. That will be enough. Cool. Resource group that could not be found. So it wants an existing resource group. It said we are using what? East Europe. as West Europe. Just create that AZ24 RG. RG is created. Cool. Let's hope this allows us to do what we want. So it's running. So it does not tell me that my account does not support this. Well, it's still running. We'll come back. Okay, cool. It has actually deployed everything. So it seems. Folio. Just do that. That failed, right? It's more like the AI template. Trying to figure out what's going on. As it look like storage is loading on the portal. Let me try a hard refresh. See what that sometimes. Oh, that's your portal. This is taking way too long. Come on, come on, come on. That's good. Okay, cool. So it created my storage account. Inside my storage account, if I go to storage account, containers, there's nothing in there. You just create a storage account and nothing. Okay, that RG has a storage account. Or then if you look at that, it has a premium storage account that has a locally redundant storage, right? Then if I put anything in here, if I create a blob, it will create all of those. So it doesn't have the file shares and da 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 da. Because if you remember when we created the storage, we actually specified on the command that we are creating a blob storage account type. So that's what happened. Julio, thank you for that. Did that source group just now. That's that. Manage blob lifecycle. Okay. Manage blob storage lifecycle. Explore Azure blob storage lifecycle. Some data set are really accessed after a while in storage. Some expire while others are actively read and modified throughout their lifetimes. So this is taking us back to what we were talking about with the access tiers hot cool thingy. Storage. Archive access tier can only be set on blob level, while hot and cool can be set on account level. So you can set up the whole account to be what you call hot or cool, and you can set up archive only on the blob level, following consideration of that. Yes. Okay. The access tier can be set on the blob during or after upload. Only the hot and cool access tier can be set. Account level, data in cool, access tier slightly lower availability, but still has high durability, retrieval latency, and throughput characteristics similar to hot. Data in archive access tier is stored offline. So that's the hydration part that we're talking about. The hot and cool tier support all redundancy options, storage, archive tier. Okay, this is the limitations. Archive tier only supports local redundant storage, geo redundant storage, and I don't know what that is. Global redundant storage. Uh, Data storage limits are set to at the account level and not access tier. You can choose to use all of your limit in one tier or across all three tiers. Okay. And is the data lifecycle. Azure Blob storage lifecycle management is a rule-based policy. So we have a rule-based policy for general purpose V2 and Blob storage accounts, right? Used to transition data to appropriate access tier according to the policy. The policy lets you transition Blob to cooler storage tier to optimize cost and performance. The policy also lets you delete blobs at the end of the life cycle. It allows you to define rules to be run once per day at the storage account level. Apply rules to containers or a subset of blobs using prefix and filters. Right? That just checking off. Still have a long way to go. Still have a long way to go in that module. I don't like these long videos because the captions become long and miss details. Right. When we come back, we'll just talk about Discover Blob storage life cycle. I'm just cutting the video here. So, call you on.